Hey guys, do you still remember what atomic orbitals are? Great! Then let's start right away with how the orbitals are occupied by electrons. We know that orbitals describe the likely whereabouts of electrons. But the electrons aren't randomly distributed in the orbitals. There's a specific allocation scheme that always has to be followed. And let's take a look at that right now. For every atom, electron occupation begins at the lowest energy level, namely at the 1s orbital. That's the first orbital located around the atomic nucleus. We've shown you two different representations here to make all this easier to understand. On the left, you see the schematic view, and on the right, you see the Pauling notation, which you might know as box notation. Okay, then let's start with the 1s orbital. In this round orbital, we can put 2 electrons, and then that part's already full. The basic thing to remember is orbitals are always full when they have 2 electrons. The next step is to fill the 2s orbitals with electrons. And do you know how many electrons? Exactly! The 2s orbital is also full and happy with only 2 electrons jetting around in the spherical orbital. After the 1s and the 2s orbital, it's up to the second energy level. This means the 2p orbital, which consists of 3p orbitals. Small reminder, the p orbitals were dumbbell-shaped parts. Now with these, there's a special feature. A distinction is to be made here between the px, py and pz orbitals. In the model, these are placed symmetrically on the respective axes. So we have 3 2p orbitals at one energy level. Electrons always occupy the atomic orbitals 1s to 2p orbitals in the same order. So basically, you check one off and keep going. Orbitals are always filled according to what's called Hund's rule. It states that orbitals at the same energy level are fitted with 1 electron each. When each orbital has 1 electron, double occupancy can begin. The 2p orbitals are followed by the 3s, 3p, 4s, 3d orbitals and so on. Does all that sound theoretical to you? Then let's look at it using an example. But before that, here's a short checklist of things you should always keep in mind when filling atomic orbitals. Firstly, an orbital is only fully occupied when it has 2 electrons. And secondly, s orbitals always have 1 orbital at 1 energy level that can allow for double occupancy, whereas p orbitals are split up into 3 orbitals at the same energy level. This means that the 1s and the 2s orbitals are fully occupied with 2 electrons each. However, the p orbitals, which are divided into px, py and pz, can accommodate a total of up to 6 electrons, since the x, y and z orbitals each take 2 electrons. To make this easier to understand, now let's take a look at the example we promised. Let's go ahead and take the element oxygen. Oxygen has 8 as its atomic number in the periodic table. What this means for us is that we've got 8 electrons that need to be distributed among the respective orbitals. Well then, let's get going. First, we fill the spherical 1s orbital with 2 electrons. Then the 2s orbital. Nice! That takes care of 4 electrons. Now there are 4 electrons left over for the 2p orbitals. According to Hund's rule, the 2p orbitals are first filled with 1 electron each. Alright, let's listen to Friedrich Hund and do this. All of a sudden, only 1 electron is left, which has to be put somewhere. Only when all 2p orbitals are fully occupied does double occupancy begin. Right, so we just stick to the last electron in the 2px orbital and double occupy it. That's about it. Not all that hard, is it? Now all that's missing before wrapping up is a glimpse into the electron configuration. Let's stick with oxygen. The electron configuration of oxygen is 1s superscript 2, 2s superscript 2, 2p superscript 4. Okay, so far so good. Do you also have an idea of what that could mean? Exactly. What this indicates is which orbitals the electrons are located in. The number 1 or 2 indicates the respective main shell. The lowercase letter s or p describes the respective type of orbital. And the last but not least, the superscript number indicates the number of electrons found in the orbital. If we add up the superscript numerals, we get back to the number 8, which indicates how many electrons oxygen has. All clear? Then let's take another look at what you need to remember about atomic orbitals. Number 1. You should know that an orbital is a space where electrons are most likely to be found. Number 2. You know the different types of orbital and know that each orbital always takes up to 2 electrons. You also know that the s orbitals are made up of 1 orbital and p orbitals are made up of 3 orbitals. And that's important for how electrons are distributed across the different spaces electrons can be found. Up for more? Then have a look at our other videos. See you later, guys!